So here, you're not given the function you're trying to optimize. You're asked to find the maximum vertical distance between the two graphs. Okay, that's what you're asked to find. Can we find a formula that will give us the vertical distance between these two graphs? That's what we've got to try and find. Now, if I draw these graphs, they're roughly like that. Okay, pretty poorly drawn. But what are we trying to do? We're trying to find this maximum distance there, right? That's what we're trying to find there. Okay. So we're trying to find the maximum distance, the maximum difference between these two functions. So how do you find the difference between two functions? How do you find the difference between 12 and 7?
Differentiate.
No, simple question. How do you find the difference between 12 and 7? Subtraction, yeah? We're going to subtract one from the other. Which is we going to subtract?
The 2 minus x, because it's a negative x.
Which is, so you're going to say, you're going to go this one minus this one?
Yeah.
Who else wants to do that?
No.
Why not?
The second one, the first is like this.
Yeah, if you look at the graph, you want to try and do that one minus that one. The biggest one minus the bottom one, don't you?
Yeah.
Difference between 12 and 7, you want to go 12 minus 7, you don't want to go 7
I
minus
just
12.
don't like negatives.
Yeah, no one does. Okay, so here is my function for the difference between my two equations. It's going to be 2 minus x squared, the first one, and we're going to subtract the second one, x squared minus 2x minus 10. You happy with that? Let's get rid of the brackets and collect all our like terms. That's going to become 2 minus x squared minus x squared plus 2x plus 10. Is it not? Just subtract it from the bracket. So it's going to be minus 2x squared plus 2x plus 12. So there is my function for my distance between my two, or the vertical distance between my two graphs. Happy with that? Now what am I trying to do?
So differentiate and solve 0.
The maximum for this particular function. Okay, so let's differentiate that. dd by dx. That is going to be negative 4x plus 2. Let's draw that plus 2 properly. Everyone happy with that? Maximum turning point refers to what? Maximum turning point implies that my gradient function is equal to 0. So therefore, negative 4x plus 2 equals 0. So 2x equals 4x, divide by 4, and you get x equals 1/2. Is that right?
Oh my god.
So x equals, can everyone see that?
No.
So it's at this x equals 1/2. This is where x equals 1/2. Right there, this is its maximum. But we're asked to find what is the maximum distance. We're not asked to find what x is.
What's the half?
Pardon?
What's the half? What does that mean?
That's where that's the x value where the maximum distance occurs.
Oh.
Okay.
Which one?
Which one what?
Did you use 0.5 to put back into the...
What did you get?
Okay. So if this is our distance function just here, we're trying to find the distance when x equals 1/2. So the distance when x equals 1/2. Negative 2 lots of 1/2 squared plus 2 lots of 1/2 plus 12. 1/2 squared is 1/4 times negative 2, that's negative 1/2. Plus 1 plus 12 gives me an answer of 12 and a half.
Is that what I said?
So what is the
I got the
maximum distance between these two graphs?
12 and a half. So
12 and a half.
find the coordinates where the two graphs are.
Why do you need to find that out?
Genie, you can put a bracket.
So what we've done is we've found the greatest vertical distance. Because the way we've done it, we haven't had to find the other two parts, but that's the greatest vertical distance. What we need to say is, as the question states up there, determine the coordinates of the 2 points to make sure that this maximum, this half, 12 and a half, actually lies within where the 2 graphs are set. Happy with that? Okay, so how do I do that? How do I do that? What am I trying to find? I'm trying to find whether this graph here equals that graph there. So I'm trying to solve those 2 graphs simultaneously. Alright, so let's write them down. So it should be y equals 2 minus x squared and y equals x squared minus 2x minus 10. Is that right? Okay. How do we solve those simultaneously?
Equal each other.
Equal each other. Okay, so I'm just going to say this here is actually like that, isn't it? So it's like that. Equal the same thing. Bring them over because it's a quadratic. Okay, how do I solve that quadratic? Factorise, ideally you can factorise. Factorise that again. So it's going to be x minus 3, x plus 2. So x is going to be negative 2 and 3. So that's where those 2 graphs will intersect. So in other words, looking back up at our graph, that one there, negative 2, that there is 3, not necessarily the y-axis, but in our maximum distance lies in between there, doesn't it? So we happy with that? What's the key with that function, or that equation there, that question? What was the key thing we had to do? We had to find the function that we were trying to optimize, okay? Find the function we're trying to optimize. Now that's going to be the hardest thing for us to do at some stage, okay? And there's going to be other versions. We're going to use parametric equations. We're going to have chain rule type scenario with that, but that's what we're going to try and do. Questions? All right.